All right, so today we're going to talk about the pH scale as well as the pOH scale. Now, I don't believe I have the scale actually in the notes, so I want to write it here, and you can write it somewhere in your notes. But if you're looking at, say, the pH scale, and if you go from, typically from 0 to 7 to 14, now, do keep in mind that the scale can go below 0 or can go above 14. Also, we'll also be working with what's called the pOH scale, and it is the opposite. In other words, it moves in the opposite direction. So, and you'll see me talk about if the pH is 1 and the pOH is 13, that represents for an acidic solution. So when you're looking at this, from 7 to 0 for pH and 7 to 14 for the pOH, this represents the acidic side of the scale. And then from here, okay, this represents the basic side of the scale. Okay. Typically, normally, especially College Board likes to talk about the pH scale, but they will throw in like pOH. And it's probably just easier to take the pOH and change it to pH to focus on that. All right. So I wanted to write that up there just to kind of help out. So if I gave, say, you have pH is equal to 3 and the pOH is equal to 11, then we can say that that's what? An acidic or basic solution? An acidic solution because of where it falls in the range there. Good. Okay. The reason why it does that is what we did on Tuesday, I believe, where we have hydrogen times hydroxide equals, do you remember what it equals? Negative 14 or love, yeah. Okay, so as one of these values goes up, the other must, to maintain this, must go down. So if I have, say, hypothetically speaking, hydrogen, where it equals 1.00 times 10 to the negative 3, which equates to that, then my hydroxide will be what? That's right, 1.00 times 10 to the negative 11. And how did I get that? Because I took 1.00 times 10 to the negative 14 divided by 1.00 times 10 to the negative 3, which gave me 1.00 times 10 to the negative 11. So that translates into those. And we're going to do the calculations to get you there. So it's an inverse scale because the values, if one goes up, the other must go down. Which is a good question. Nobody asked that in the first hour. I agree. Michael, I like your thinking. Oh, I'm sorry. Okay. I guess we're not going to erase it all. My smart board is dumb again.
Smart again? You mean a dumb board?
Yeah, my dumb board is. Yeah. All right. So, and again, I will give you, and I'll write down as we start to do the calculations, what I'll provide you with. And here is one of the equations that we're going to do. pH is equal to the negative log of the hydrogen concentration. Better stated, anytime you see P in front of something, okay, because in here we'll only do pH and pOH, but next year we'll do pKa, pKb, pKw, pH, pOH, all those fun things. The P simply means it's negative log, okay, of whatever that thing is that we're doing. So it's a negative log function. Okay. So if I were looking for pOH, then I'm going to take the negative log of what, do you think? The hydroxide. Very good. Okay. And I would give you that. Actually, I'm going to skip that right on over since I already have it. So I don't have to rewrite it. So I'll keep that right there. Okay. And there's also another way that if I gave you hydrogen concentration, you could find the pH rather easily. But if I gave you hydroxide, you could do it this way, because another thing I'll give you is that pH plus pOH is equal to, anybody remember? That's right, 14. Yes. Woo. You guys are so smart. I appreciate that. Okay, so those are two of the many that I'm going to give you. I would not give you this, though. I'm not going to do that. You can actually formulate this based on using these two equations. Obviously, you're going to have this one, which is pH is equal to the negative log of the hydrogen concentration. Actually, let's move that down up. Right there. Okay, so there's... And there you have your pH plus pOH equals 14. I'm just kind of writing those out because when we get to the calculations, they're going to be super fun to use. And what this information here is showing, is what that scale was talking about. So if you have a pH that's bigger than 7, you're looking at a basic solution. If you have a pOH that's less than 7, you still have a basic solution because they're inverted. Obviously, neutral means what? They're both 7. And how do we derive that value? 7. That all goes back to this. So if you have hydrogen times the hydroxide, it equals 1.00 times 10 to the negative 14. And if I have equal amounts of this, what must this concentration be equal to? Or if you took the square root of 1.0 times 10 to the negative 14, what does that equal? That's right, 1.0 times 10 to the negative 7. And you guys are like human calculators in there. I love it. So if I take the negative log of 1.0 times 10 to the negative 7, that would give me a pH of 7. And if I took the negative log of, for the hydroxide of 1.0 times 10 to the negative 7, that would also give me 7. So that's a concept that sadly you guys don't have to know in here, but I'm sure they will. Okay. So that's how we get neutralization being a pH of 7, because the hydrogen and hydroxide are equal at that point. Okay. All right, here's some examples down here of working out some problems, but it's a lot more fun when we work them out together. All right, so let's look at this first one, number 9. Number 9 says, calculate the pH of a 0.01 molar nitric acid solution. And it says that nitric acid is a strong acid. For what we're doing in here, all of the acids and all the bases will be strong. Okay, so we'll be using this technique. So if the pH is this, and I'm given a hydroxide concentration, I'm looking for the pH, and I'm given that, should I use this equation here? Yeah. So pH is equal to negative log of what I have there, 0.01. Okay. Now, here's where we have to use our calculators wisely. If you have a 2-line calculator, in other words, as you type stuff out, and then when you hit enter, you still see everything that you wrote out, type it in as you see it, negative log 0.01. If you have a single-line calculator, does anybody have a single-line calculator? No, you got 2-line if it's pink. Somebody has a single-line in here, I'm pretty sure. Who has it? No, that's a 2-line. That's a 2-line. Because when you type it in, that the work that you typed in still stays when your answer appears. All right. Somebody probably does have one. If you have a single-line calculator, you have to work backward. If you have a 2-line calculator, you type it in as is. So single-line people would type in this first, then log, then the negative. Now, this is a negative, not a subtraction. Don't type in minus log. Okay? Use the negative button. What's that? No. 2-line is negative log 0.01. 2 lines, type it as I write it, which is normal. But if it's a single-line calculator, the calculator has to work backward to get to the answer that we're looking for. What did you get, Celeste? 2.0? All right. 2, okay. Now, when writing down pH and pOH values, this is really important. Be sure that you always, always, always show 2 decimal places. There are no sig figs with pH and pOH. Okay? So again, whenever writing pH or pOH, always show 2 decimal places. Don't show more, don't show less. Show 2 decimal places. What's in front? Okay. Sometimes you might have 2, sometimes you might have 12. Okay. Good news is this will never get higher than 20 for what we're doing. No, we're proving that the pH is 2. So we're just calculating what is the pH for this acidic solution with that concentration. Okay. Let's do another. All right, the next one says calculate the pOH, okay, of a 2.33. So again, calculate the pOH of a 2.33 molar solution times 10 to the negative 4 molar solution of sodium hydroxide. So now, are we using pH or pOH? pOH, so we're using that equation. Do we have the hydroxide concentration here? Yeah, whenever you see hydroxide, again, we're going to say that it's strong. That's its concentration. Okay. Now, next year it gets a lot more fun, but this year it's super easy. So to find pOH, take the negative log of your value times 10 to the negative 4. Okay. Now, as you saw on the last example when you typed in negative log of 0.01, and the answer was 2. Did anybody pick up on the trick there for logarithms? Log is, for what we're doing, is base what? 10. Base 10. Okay. Natural logs is 2 point something. We don't care about natural logs. So when we're talking about base 10 for our logarithms, if you had, like in the last problem, 0.01, that equals 2.0. Okay. Let's see if your mental math is great here. If I had 0.001, what should my pH be based on logs? 4. How did I get that? Because I moved the decimal place 4 places. So when your number is 1, then that's, the 4 represents how many times you move your decimal. So if you saw a number like this, because in AP we have to be able to do this mental math, our answer is somewhere between 1.00, or I'm sorry, this concentration is between 1.00 times 10 to the negative 3 and 1.00 times 10 to the negative 4. Which means that my answer should lie somewhere between 3 point something. 6.3? Okay. And here's the reason why. Is 2.33 times 10 to the negative 4 bigger or smaller than 1.00 times 10 to the negative 4? Bigger. That number's bigger. Is 2.33 times 10 to the negative 4 bigger or smaller than 1.0 times 10 to the negative 3? Smaller. So that means that it falls between 3 and 4, which means that's a good number. So that's a check you can do. So when you're looking at your exponent, say, if that's a negative 6, my answer should be between 5 and 6. Okay? If it's not 1. If it's 1, then it's super easy. Okay? Now, I am not going to require you in this class to be able to do that, but that is a real quick check if you're like, it should be somewhere around 3 point something. Okay? All right. Let's look at the next practice problem. Trust me, you're going to have your calculator for all your problems that you're doing in here. Let's look at the last one, number 11. Sorry, not the last one, but number 11. It says, calculate the pH of a 0.00458 molar lithium hydroxide solution. So it's asking for pH, but it gave us a hydroxide concentration. So we're going to use this. If we're working smart, we'll use this and this, right? Do we want to use these 2 equations? That would be working smart. Because since you're given a hydroxide concentration, find the pOH, then to find the pH, just take the answer minus 14, or 14 minus your answer. Okay, now, trust me, there are much longer ways that we can do this, but I'm going to try to show you the most efficient way. So since we're looking for pH, but we're given a hydroxide concentration, let's find what the pOH is. So negative log of our hydroxide, 0.00458. And should that fall between a pH of 3 and 4? What? Should our answer fall between 3 and 4? Yeah, Kate, I'm sorry. Or 2 and 3, I'm sorry. Yeah, you're right. So 2 and 3. So what'd you get? 2.34? There we go. And then to find your pH, then we're going to do 14 minus that. Or in this case, our OH. Okay? So 14 minus 2.34. So that's around, what is that? 11.66. Okay. Okay. You can do that. Or, remember on the front where we had 14 minus this? This too would work. In other words, we're incorporating those two equations into one. Whichever you show me, make sure you're showing the whole process. Okay. Now, what I would need to see is this minimum. Oh shoot, I erased the pH. Okay. If you're showing this process here, this would be the minimum work I would need to see. If you're showing this, okay, you would just have to show that into there and then your answer. Okay? But don't just write an answer down based on what your calculator said. Show me how you're getting those values. Make sense? All right. Now, how do I know to do 2 steps for this one? Okay. Because it was giving me a pH, but it gave me a OH concentration. So if I'm given a hydroxide concentration, typically I'm going to find a pOH. Once I have my pOH, then I can find my pH. Okay. So that's why it's really important to read what this thing is. And if it says an acid, the acid name has the word acid in it. You know that's not an acid for 2 reasons. Because it's hydroxide and it doesn't have the word acid in it. Okay. So that makes it kind of nice. All right. Now, since we did logs and we were finding pH, is it possible to go in the opposite direction and say, okay, I'm giving you a pH, but now I want to find the hydrogen concentration or the hydroxide concentration? Yeah. And what we do to do that, if I want to find the hydrogen concentration, I'm going to find the antilog of my pH, but I want to find the negative pH. Okay? Antilog on your calculator typically is a second, and generally if you have a log button on your calculator, you might see 10 to the, ooh, that's not 10. You might see 10 to the x right above it. For a lot of calculators, that's the way it is. If not, you have to punch a series of buttons to get to the 10 to the x. 10 to the x, and I'm not talking times 10 to the x. Those are 2 different critters. Okay? This would be located with the log button. That is the antilog. Okay? So we would take, find the hydrogen concentration, take the antilog, which is your second log, times, or just minus pH. If I wanted to find the hydroxide concentration, I would do the same thing. Antilog of what? Yeah, the pOH, so negative pOH. Okay. Those would be the 5 equations that I would give you. Okay. And knowing which one to use at the appropriate time is pretty important. So let's work out the first.
You can still do that first way we did for that problem, right?
Say that again.
Like the first way we did it with pH plus pOH, but like we found pOH first and then subtracted by 14.
You may. Yeah, but for a problem like number 12, okay, it says, what is the, oh, and here's another thing I need to clarify, because I see this quite a bit now. Hydrogen concentration and hydronium concentration are exactly the same thing. Okay, it's just worded differently. In other words, the hydrogen's actually attaching itself to the water molecule, but historically speaking, this is the way I was taught in high school and college, but this is also true. Okay, so if you see this, translate to that, And you'll notice that I do that all the time with hydrogen ions. And College Board flips back and forth as well. So just make sure that if you see this, translate it to that. Okay. All right, so here it wants us to find the hydrogen concentration where you have a pH of 3. Okay. So here, we do the antilog of the pH, which is negative 3.0. Now, the key here is we have to make sure that your pH is a negative value, because if you didn't, that would be a positive big number, like 1,000, I think, in this case. So in this case here, actually, let's just write equals. Anybody get a number for this? Yeah. So 0.001 or 1.0 times 10 to the negative 3. Okay. Awesome. You may. However, that's the most zeros I want you to write. Okay. Okay. Hit second log. Second button, log. Is it? There are some funky calculators. Mitchell has one. Ashley has one. Those are a little more complicated in finding anti-log and log. Would you not agree? Or is there a button that's second log on those? Oh, good. Then it's not those. Does anybody have a black version of what Ashley has? And it has like a little bullet in the middle. I hate them. They're the worst. I don't see any around, thank God. I saw one last hour. Everybody else has normal calculators. That's good. Good. Because in some cases you have to hit like a menu to go find logs, and then it's just like, man. What's that? No, I recommend that at the beginning of the year get a 2-line calculator, but for the most part. And these are generally on sale at the beginning of the year for like $10, so grab them. All right, let's take a look at number 13. Yeah, so very good. So in this last problem, we just use that guy. And for hydroxide, same thing. It's just, yeah, your process is similar. I like that. So we have hydroxide concentration, and we're given a pOH. So now we're going to use this equation right here, right? So to find the hydroxide concentration, just take the antilog. And again, if you want to write 10 to the, and I'll do this simultaneous here, 7.55 or 7.55, those are both legal. Okay. Anybody get a number? Times 10 negative 8. I like it. Yeah, 2 point what? All right. Did you count it over, or did you do second DRG? Okay, no, hang on. So now go second DRG. DRG arrow 1. There you go. So 2.82. Yeah, your count. Don't count zeros. Always let the calculator work for you. Was that negative 8? Okay. Yeah, you don't work for the calculator. Let it work for you. Put it to work. Put your money to work. All right, everybody feeling good? Ready for number 14? 14. 14's the challenge. I'm telling you. There is a hard way of doing this one, and there's an easy way. Shall I show you the more difficult way? No. Oh, no. We don't do it the long, difficult way. We do it the smart way. All right, just for you, Celeste. All right, Celeste, you tell me. How would you do this if we're looking for a hydrogen concentration, but I gave you a pOH? We already had the pOH, so we don't want to find it. We found it. It's right there. So so you want to do this? pH plus pOH equals 14. So what you're telling me is you want to find the pH first. Is that what I'm hearing? I want to clarify. No, you already have the pOH. I want to find the pH, right? Because I'm looking for the hydrogen concentration. So do 14 minus pOH. So 14 minus 2.45, is that like 11.55? Does that make sense? And now that we have the pH, then we can do the antilog. Yeah. Okay, to get the hydrogen concentration. So here's what I'm suggesting. Always look at the problem and ask yourself, there's got to be an easier way than the way I'm thinking. Okay, there's always the more adventurous way. I'm never upset by that as long as you're showing all your work. But in this case here, we're going to find the pH and then find the pOH based off of that. So at this point, plug and chug. Okay, go right there. Getting worried about you, Bubby. Yeah, Abby, I'm sorry. Oh, okay, go ahead. Awesome. What did you ask, Celeste? I'm sorry. Awesome. So the homework is the 5s and 6s. If you didn't write this down, I probably would, just to have it nearby. You will get those for the test and quiz. Okay, it's just a matter of using them in the appropriate fashion.